Question number 9 in the homework 6.6 to 6.7. So hybridization experiment, they have in total 580 offsprings, and they assume that 25% is the correct rate to have for the yellow pods. So instead of getting 145, they get 151. And what they are asking is all of the following. So first, you list down what is n. N is 580, p is 0.25, and q is 1 minus p, which is 0.75. And number 1, you need to check what is n times p and what is n times q. Are they all bigger or equal to 5? Because that is a requirement for the normal approximation. So basically, you just plug in your n, p, and q as listed here. I will omit this step. I think you already know how to do that using the calculator. And because this one is satisfied, your x is approximated with the normal distribution with mean equal to n times p. Sorry. A standard deviation equal to the square root of n times p times q. So now you want to calculate those two. You go to data, compute, expression, and what you want is 580 times 0.25. That's your n times p. You copy your number here. And for the next one, you still want to use StatCrunch to do that. So you go to the edit of this window. So you plug in sqrt of this one, n times p times another 0.75. So this number is, if you copy that, that will be your standard deviation. Okay. And then let's see what they are asking. They ask by the probability that exactly 151 have yellow pods. So exactly, so if you go to this table again, so exactly is basically from this number minus 0.5 to this number plus 0.5. So this little strip has an area equal to that probability. So what you do is say exactly 151, so you need to know your x from 151 minus 0.5 to 151 plus 0.5. So this is for part way, the probability you want to calculate. Okay, so you have everything. You are ready to plug into the StatCrunch. So for the StatCrunch, if you find the window from Stat Calculators Normal, which I already have a window here, so I will not open another one. So for this one, if you plug in mean equal to 145, standard deviation is at 10 point something, which you calculated before. Yes, and you choose between because you have both the left boundary and the right boundary. So it's 150.5 to 151.5. You click that probability, which is this one, shown on the right. So if you copy that number here and use to round to the first decimal place, so it's this 0.0324. Let me see. Okay, and then for part B, basic setup, you want the probability of at least 151 have yellow pods. So at least, if you go to here, at least it's a basic right area. The boundary is whatever this number minus 0.5. So for this one is, for part B is for the P of the right area, so X bigger than 151 minus 0.5, minus 0.5, okay? So that's basically you go to standard because you only have the left boundary, bigger or equal to 150.5, which is 151 minus 0.5. So this should be the thing you want to calculate. So that's a probability. So this time, because the fifth place is 5, you have to really round up. So it's 2.2990. Okay. And for which result is useful to determine whether the claimed rate 25 is incorrect. As we have said in the class, our assumption is, suppose 0.25 is correct, and if we find that 151 is an unusually high number, then we will say 25% is incorrect. Then how to determine whether 151 is unusually high? We will use part B. We say that the probability of X exactly equal to some number is not important in this case. We want to include the outcomes of exactly equal to and all extreme values, all more extreme values, I mean. So part B is more important. And then for part B, D, is there strong evidence to suggest that 25% is incorrect? We want to compare this number in part B with 0.05. Because this number is bigger than 0.05, let me write that down. Okay, so because this probability, which is 0.2990, because it's bigger than 0.05, we say that 151 is not an unusually high number. So we will keep assuming we'll keep assuming 25% is correct. So we do not have enough evidence to say that 25% is not correct. So we'll keep assuming 25% is correct. So is there strong evidence to suggest that this is incorrect? No.